AI-managed education system, prototype, not for commercial use. AI-managed education refers to the use of artificial intelligence, AI, to manage and personalize the learning experience for students. Here are some potential benefits and applications of AI-managed education. Benefits. 1. Personalized learning. AI can help tailor the learning experience to individual students' needs, abilities, and learning styles. 2. Improved student outcomes. AI can help identify areas where students need extra support, enabling targeted interventions to improve student outcomes. 3. Increased efficiency. AI can automate administrative tasks, freeing up teachers to focus on teaching and supporting students. 4. Enhanced teacher support. AI can provide teachers with real-time feedback and suggestions for improving their teaching practices. 5. Accessibility. AI-managed education can help make learning more accessible for students with disabilities or those living in remote or underserved areas. Applications. 1. Intelligent tutoring systems. AI-powered systems that provide one-on-one support to students, offering real-time feedback and guidance. 2. Adaptive learning platforms. Platforms that adjust the difficulty level and content of course materials based on individual students' performance and learning needs. 3. Natural language processing. AI-powered tools that can analyze and understand human language, enabling more effective communication between students, teachers, and AI systems. 4. Predictive analytics. AI-powered systems that can analyze large datasets to predict student outcomes, identify areas of improvement, and inform educational decision-making. 5. Virtual learning environments. Immersive, interactive learning environments that use AI to simulate real-world scenarios, enabling students to practice and apply their knowledge in a safe and controlled environment. Challenges and limitations. 1. Data quality and bias. AI-managed education requires high-quality, unbiased data to function effectively. 2. Teacher training and support. Teachers need training and support to effectively integrate AI-powered tools into their teaching practices. 3. Equity and access. AI-managed education must be designed to ensure equity and access for all students, regardless of their background or socioeconomic status. 4. Transparency and accountability. AI-powered educational systems must be transparent and accountable, with clear explanations of their decision-making processes and outcomes. 5. Human touch and empathy. AI-managed education must not replace human teachers and mentors, but rather augment and support their work, ensuring that students receive the empathy and support they need to succeed. The Python program analyzes Python program student performance data using linear regression and visualizes the results using Plotly. It begins by defining a dataset containing scores in math, science, and English for 10 students and computes their overall scores as the average of these subjects. The data is split into training and testing sets, and a linear regression model is trained to predict the overall scores based on the individual subject scores. The program calculates the mean squared error, MSE, to evaluate the model's accuracy and uses the trained model to predict the overall score for a new student based on their subject scores. The program also visualizes the relationship between actual and predicted overall scores with a scatter plot, created using Plotly. The scatter plot displays the predictions, along with an ideal prediction line for comparison, against a dark background for enhanced visual appeal. Additional layout customizations, including a descriptive title, axis labels, and a transparent legend, improve readability. The plot emphasizes data-driven insights and highlights any discrepancies between the model's predictions and the actual scores. Using this Python program, you can generate various reports and graphs to analyze and visualize student performance for all levels of the school. Here's a list of potential outputs. Reports. 1. Overall score report. Displays each student's overall score calculated as the average of math, science, and English scores. Can be extended to include class-level or grade-level averages for comparison. 2. Subject-wise performance report. Highlights scores in individual subjects, math, science, English, for each student. Includes top-performing students in each subject and the average subject scores. 3. Student ranking report. Ranks students based on their overall scores. Identifies the top scorers and low scorers for targeted support. 4. Prediction accuracy report. Compares the actual and predicted overall scores, along with error metrics such as mean squared error, MSE. Summarizes the reliability of the prediction model. 5. New student performance prediction. Provides predicted overall scores for hypothetical students based on input subject scores. 6. Performance gap analysis. Highlights discrepancies between predicted and actual scores. Useful for identifying areas where predictions are less accurate. 7. Class or grade level summary. Aggregated statistics like average scores, standard deviation, and performance trends for each class or grade. Graphs. 1. Predicted vs actual overall scores scatter plot. Visualizes the correlation between actual and predicted scores. Includes an ideal prediction line for performance assessment. 2. Subject-wise distribution graphs. Histograms or box plots for math, science, and English scores. Reveals score distributions and outliers for each subject. 3. Overall score distribution. Histogram or density plot showing the distribution of overall scores across students. 4. Student performance comparison. Bar chart comparing subject scores for individual students. Can highlight strong and weak areas for each student. 5. Top performers in each subject. Horizontal bar charts or pie charts showing the top performing students in math, science, and English. 6. Trend line for grade level performance. Line charts showing performance trends for different classes or grades over time, if data is extended. 7. Prediction error analysis. Scatter plot or bar chart displaying errors, difference between actual and predicted scores, for each student. 8. Subject correlation heat map. Heat map showing correlations between scores in different subjects. Helps identify if strong performance in one subject is linked to another. By extending this program, you can tailor these reports and graphs to specific use cases, such as identifying performance trends across semesters, assessing the impact of interventions, or supporting administrative decision-making in schools. Few outputs from AI/ML model. Python program bar chart for new student performance prediction. Provides predicted overall scores for hypothetical students based on input subject scores. Let's break down the information presented in the image you sent. Image description. The image displays a combination of bar charts and line charts to visualize the predicted overall scores for 4 students, Student A, Student B, Student C, and Student D, over 3 years, 2025, 2026, and 2027. Bar charts. 2025, this bar chart shows the predicted overall score for each student in 2025. Student A, 89. Student B, 92. Student C, 79. Student D, 91. 2026, this bar chart shows the predicted overall score for each student in 2026. Student A, 91. Student B, 95. Student C, 81. Student D, 92. 2027, this bar chart shows the predicted overall score for each student in 2027. Student A, 95. Student B, 97. Student C, 85. Student D, 93. Line charts. Student A, this line chart tracks the predicted overall score for Student A over the 3 years. Student B, this line chart tracks the predicted overall score for Student B over the 3 years. Student C, this line chart tracks the predicted overall score for Student C over the 3 years. Student D, this line chart tracks the predicted overall score for Student D over the 3 years. Overall observations. Student B consistently has the highest predicted scores across all 3 years. Student A shows a steady increase in predicted scores. Student C also shows an increase in predicted scores, but at a slower rate than Student A. Student D has the second highest predicted scores in 2025 and 2026, but falls behind Student A in 2027. Additional notes. The image title indicates that these predictions were made using an AI model by Pradeep K. Suri. The y-axis represents the predicted overall score, ranging from 0 to 100. The Python program brief which is used in prediction the overall performance scores of 4 students, A, B, C, and D, for 3 consecutive years, 2025, 2026, and 2027, based on their subject scores in math, science, and English. It uses a linear regression model trained on sample student data to predict the overall scores. The program calculates an overall score for each student by averaging their subject scores and then splits the dataset into training and testing sets. After training the regression model, it evaluates its accuracy using the mean squared error, MSE, and uses it to predict scores for hypothetical students over the 3 years. The visualization combines a bar chart, to display yearly scores, and a line chart, to track trends for individual students over the years. The bar chart groups scores year-wise, while the line chart connects each student's scores across the 3 years, allowing for easy comparison. The program employs the plotly.graph_objects library for dynamic, interactive visualizations, with features like vibrant colors, text annotations, and a modern dark theme template. The output showcases the predicted performance trends for each student, offering clear insights into their progression over time. Python program subject correlation heat map. Heat map showing correlations between scores in different subjects. Helps identify if strong performance in one subject is linked to another. The Python program is designed to calculate and visualize the correlation between students' scores in different subjects, math, science, and English. It begins by importing necessary libraries such as pandas for data manipulation, plotly.graph_objects for creating an interactive heat map, and Seaborn and matplotlib.pyplot for potential future visualizations. The program defines a dataset containing student IDs and their corresponding subject scores, then creates a pandas data frame from this data. The correlation matrix is computed using the CORR function, which measures how closely the scores in different subjects are related. The program then uses plotly.graph_objects to create a heat map, where the correlation values between subject scores are displayed as a color scale. This heat map is interactive, allowing users to explore the data visually. The color scale is set to varieties for aesthetic purposes, and the range of correlation values is standardized between -1 and 1, where 1 indicates perfect positive correlation, -1 indicates perfect negative correlation, and 0 indicates no correlation. Finally, the layout of the heat map is customized with titles for the axes and a dark theme, providing a clear and visually appealing representation of the correlation between the subject scores. The video is a correlation heat map. It visually represents the correlation between different subject scores, math, science, and English. How to interpret. Colors. The color intensity represents the strength of the correlation. Dark yellow indicates a strong positive correlation. This means students who score high in one subject tend to score high in the other subject as well. Light yellow indicates a weak or no correlation. There's no clear relationship between the scores of the two subjects. Diagonal cells. These are always dark yellow because they represent the correlation of a subject with itself, which is always 1. Observations from the heat map. Math and science. The cell representing the correlation between math and science is dark yellow, suggesting a strong positive correlation between these two subjects. Math and English. The cell for math and English is also dark yellow, indicating a strong positive correlation. Science and English. The cell for science and English is light yellow, suggesting a weak or no correlation between these two subjects. In summary, this heat map reveals that students who perform well in math tend to perform well in science and English, while there is no clear relationship between science and English scores. Note, the actual correlation values are not provided in the image, so we can only make qualitative interpretations based on the color intensity. Thank you.